back to my channel by Campire World. Today I'll be discussing how to prepare an agarose gel in your laboratory. So we usually store our solutions in stock solutions. That is, we usually prepare a more concentrated solution. For example, in case of in agarose gel, what happens? There are basically two types of buffers which we use. That is, first is TAE, trichloroacetic acid, and EDTA and TBE. What I used to do, I used TAE buffer in my research laboratory, and I used to prepare a 50x stock. Okay, I 50x stock, and my working concentration, what I used to prepare from this was 0.5x. So the first step is to prepare a working solution buffer. Okay, I transfer this working solution in a conical flask. For instance, I have to prepare a 100 ml agarose gel. What I do is I prepare a working solution and I transfer that 100 ml in a conical flask. Okay, next is you weigh the appropriate amount of the agarose. Okay, agarose comes usually in a powdered form, and I weigh, and usually what happens, the 0.8% gel to 3% are the concentrations which we usually prepare in our laboratories. If I have to quantify a genomic DNA, I usually prepare 0.8% of agarose gel. And if you have to resolve your PCR products, then what happens, we usually prepare from about 2% to 3% depending upon the product size. Okay, if your product size is approximately 1000 base pair, so you prepare 2% to 2.5%. Okay, and if your product size is less than 500 base pair, which I used to do, and I used to resolve on 3% gel. Okay, the handling of 0.8% gel is very, you need to be very careful for that, because it is usually very thin and less concentrated, so it easily breaks down. Okay, whereas handling of 2% 3% gel is very easy. Okay, you just keep a you be careful when handling 0.8% of gel during the quantification of the genomic DNA. Okay, first step is preparing the working solution. Next is transfer that in a conical flask, and the third is you weigh the amount of agarose depending upon on what you want to, how much base pair you want to resolve. For if you want to do for genomic DNA, you go for 0.8%, and if you have to resolve PCR products of approximately 1000 base pair or more than approximately 1000 base pair, you go for 2 to 2.5% gel. And if the product size is less than 500 base pairs, and it usually goes like approximately, I think, 1 to 150 base pair, you go for 3%. Otherwise 2.5% gel is most appropriate one, which I used to do in my laboratory work. Okay, you weigh agarose gel, and next is you transfer that weighed agarose in the conical flask, which is containing the working solution, that is 0.5x whatever you use buffer. Okay, it contains the buffer, and what I do is I microwave it. And you have to keep a very, we can say, very, you have to be very careful during the microwave. What happens if you do it for a large a more time, your gel becomes concentrated because the water evaporates. If you do it for less timing, the agarose won't be dissolved. Okay, you have to keep a very, you can say, check on this. Okay, and after microwaving it, you ensure it, you just swirl it in the conical flask, and you check it. If there is no powder left at the bottom of your conical flask, it means the gel has been the agarose has been dissolved and your gel is ready to pour. Okay, I microwave it, and then side by side, I think side by side you prepare the gel casting mold. Okay, and usually what happens, we have a gel mold made up of plastic. This is your gel mold, and I put spacers to prevent the leakage of the gel, or the leakage of the gel, and I add a paper tape just to make sure it does not spill. Okay, and you place the combs. You need the wells, and to make the wells in the gel we use combs, and they form wells and which you usually load your product. Okay, I have prepared my gel casting mold. I'll take that dissolved agarose in my buffer and I pour in it. Okay, so for the staining of the DNA, okay, for the staining of the DNA, you need a dye. You need a fluorescent dye. Okay, and we in agarose gel, we what we do, we add that we use ethidium bromide because due to its increased sensitivity. Okay, and what I used to do, I added ethidium bromide in that particular dissolved gel before pouring it in the gel casting mold. Okay, we usually add 5 microliter per 100 ml. Okay, and this is picked up from 10 milligram per that is 1 milligram per ml solution. Okay, and I add is per 100 ml. I add in the uh, that dissolved agarose gel, and pour it in a gel casting mold, and I keep it for 20 to 30 minutes to settle down. Usually this the in winters what happens, it usually take approximately 20 minutes, whereas in case of the summers you have to keep it for a longer time, and your gel is ready to use. And you place this gel in the tank buffer and make sure the buffer it is dipped in the buffer before loading the samples. And that was all for this preparation of the agarose gel. Thank you so much for watching my channel. Please like, subscribe and share.